So we are starting. So for people who have just joined, you have to fill in the sign-in form because that's how we keep track of the attendance for every day. So please sign in on this form. If you have signed in, how many of you have signed in already?
Oh, well, wait for
3, 4. Let's wait for a minute. And then...
Yes. But it's the other side. I haven't called it. This isn't the same as that.
Like get the details into basic LAN, WAN, something like a little faster, but then when it comes to like Nmap, AEC packets and everything, that's really take it slow.
Okay, is everyone signed in?
E-
Okay, got it. Do you need it or?
Have you joined the link? Yeah.
Okay.
So networking, not networking is talking to people. So it's not the networking that you guys have been doing up until now. So we are going to be talking about computer networks, and that's what our topic for today is. So what is a network? How many of you guys have like studied a little bit of networking in the past? I see a couple of hands. So how do you define a computer network?
It's connected to a server.
Connected to a server, that's correct. And
Computers connected together.
bunch of computers connected together. That's true. That's what's reminding me of my 9th grade definition for networking. I'm kidding. But yeah, so that is actually true. It's just a bunch of computers or devices connected together in a single network. Like that's what a network is. It's just a combination of certain devices connected to the internet, or internet can be referred to as a network where you have devices from all around the world connected together.
Yeah, the most important thing within a network is that all these devices can send and receive data amongst each other. So they have to be able to communicate. And that's the definition of interconnected. So yeah.
LAN, WAN, and these are like the two major networking like network groups that you can think of. Like it categorizes into, each network can be categorized into 2 buckets. Like the first one is LAN, which is used for smaller networks. Like let's say if you want to have, if we want to connect every device over here into a single network for us to share files with each other. So we would be creating a local area network, which is used for like smaller geographical areas such as home or small organization or a small group like this. For WAN, it is actually used for largest geographical areas. It is for cities, countries, like where if you would see the submarine cables like that go through below the ocean to connect a bunch of countries together to the internet, that's what WANs are classified for. So here you can see like in a LAN network, you have a single server, and it's a really fairly smaller network. But in a WAN, you see like it's a collection of a lot of LANs. So that's what a WAN is. It is just an interconnection of a lot of LAN networks. Like one way to think about it would be that.
Yeah, so just going off what Nasir said, a wide area network is basically just a group of networks. Example is the internet, because it interconnects many other WANs, and which these WANs connect other LANs. So yeah. Okay, so there are a lot of different network devices that you should be aware of. So one of them is a switch, and I'm pretty sure you guys probably haven't heard of a switch, but you have heard of a router. So let's talk about a switch first, because this is less than this is a smaller scope compared to what a router does. So a switch is commonly used in like most enterprise settings, because what a switch does is basically connects a lot of devices together. Usually in like a home network, you'll only like really have like a router, because you don't need to like physically connect a bunch of devices. But when you're in like a company setting, right, you're gonna have like a lot of devices, and you probably want to connect them with Ethernet, things like that. So that's when you want to use a switch, and you can see like there's 3 laptops, or if you want to call them PCs, connected to a switch, and which the switch connects to a router. But basically what a switch does is that a switch basically is like it'll man between a local area network. It doesn't go beyond the local area network. So for example, in this for the switch right here, the local area network would be right here, and then anything beyond that is another local area network. So yeah, basically what it does, it receives data packets and forwards them to the intended recipient within the same network. And how it does this, rather than with IP addresses, it does it based on the MAC address of devices. And maybe you haven't heard of that term before, but basically all a MAC address is an address that is unique to a device generated by the manufacturer. So on all your like laptops right now, your manufacturer for your laptop generated a MAC address that's unique to your device. And with using these MAC addresses, a switch can take these MAC addresses and use them to forward data to the correct destination. And then what a router does is kind of like above a switch. Think of that as like a hierarchy. But basically, a router is like the layer above a switch, and it basically does all the interaction between local area networks. Like I said, a switch does interaction between or within a local area network, but a router does it for between local area networks. So it forwards data packets between these networks, and it accomplishes this by determining the optimal path for data. So when you have like a network, right, if you're forwarding a lot of data at the same time, you want to make sure it all gets there properly, but it also gets there efficiently. For example, if you're like watching a YouTube video, right, you don't want it to like stutter. So that's like where the router can come and play. It determines the most optimal path based on algorithms, which is just like what a router does. But most importantly, it gets the packet from the source to the destination.
So here's just a question. If we want to create a network over here, which ones of these devices would you prefer to use? Would it be a switch or a router? A switch. Why?
Usually covers the where network versus the full power range.
Yes, so for a smaller network, because it would have a lot of ports to like connect every one of us, but it wouldn't have a lot of capabilities that a router has, because a router would do like the optimal path recognition and a lot of other stuff, because a router also keeps tracks of like all the routes that are there, like every computer's identity. Over here, you were like doing it using a MAC address in a switch, and as every one of us have like different MAC addresses, we can all connect to a single switch.
Just to point out, so like Nasir said, like for all of us here, if we want to connect each other to a network, you would use a switch. But if you want to go beyond this local area network and you want to connect to the internet, that's when you need a router, because that's connecting multiple local area networks, right? And it can go beyond the scope of local area networks and connect it to a wide area network, which is basically the internet, or an example is an internet. So if you want to connect to the internet, you need a router. But for locally, you would use a switch. Okay, so we have a few more devices. So one you probably like have in your home network is like a modem. And you also have a wireless access point. So what a modem is it's a device that connects a computer or network to an internet service provider. So when you have like your router, right, it also needs to be able to like communicate with your internet service provider, because your internet service provider provides your public IP address that allows you to communicate in wide area networks like the internet. And we'll talk about the internet service provider, and we'll talk about public IP addresses and why we need that. But just understand the idea of a modem, and it's like the interface between your home network, your router, to the internet or the internet service provider. And then we also have a wireless access point, and this device allows wireless networks to connect to a wired network. So it enables wireless communication between devices and provides Wi-Fi connectivity within a specific area or coverage zone. So yeah, it's very simple. It just allows like wireless devices like your laptop to connect to like a wired network.
That's so just to like summarize, it'll be the modem is used to when you are like trying to connect to a bigger WAN network, like the internet. That's when did any of you guys ever see a modem like where it was like connected to your phone line and then once you connect to it, the phone line like gets disrupted? Anyone? Yeah, so that's what a modem does. And for the wireless access point, we are all connected to the school network without any wires. So the thing that's responsible for it is the wireless access point.
And then we also have a firewall. So you might be thinking like, hey, I have a firewall on my computer, like Windows firewall, right? But that's a software firewall. There are also dedicated network devices that are firewall, so like a physical device. And basically it's a security device that monitors and controls incoming and outgoing network traffic based on like security rules that network administrators can configure. And so it just acts like a middleman or like a barrier between internal and external networks so that it can filter bad traffic and make sure that things that the network administrator didn't want doesn't come in. And you can also make configurations for traffic going out. But yeah, that's all it is. It's just like a middleman between external traffic and internal traffic.
The one that's responsible for maintaining like all the rules that all the people in this Wi-Fi network are allowed to visit these sites. So these sites are ones that are blocked. So if you would look at our school network, when we go to a site that is blocked, it would actually show a FortiGuard page that says like this IP is blocked or this website is blocked. So a network firewall is configured in like organizations to monitor their networks. And nowadays, the firewalls that are in there, they are like really smart. They have like AI embedded in them nowadays as well, which actually what it actually does is it looks for the patterns that a certain user is having on their laptop or on their device. And then it monitors like, and then it creates warnings for that certain user, or it might also create like warning for the outsiders coming into the network. So they are getting like really smart nowadays, and they are like the security point for your networks. Like they are the ones that stop people from outside to hack your organization.
Okay, so I mentioned public and private IP address, or I mentioned public address, but let's just like dive into what an IP address is. So at the core, an IP address is a numerical identifier, and it's used as a logic label for devices within a network. So think of it as like your home address. Maybe when you're like sending mail or you're receiving mail, right? It has to know where to go, right? And how computers know where to go is by this address right here. So an example IP address is just the 192.168.0.1, and at the lower level and computer form, it's represented in binary. And the reason why I wrote right there, it follows a 32-bit addressing format of 4 sets of 8 bits, each ranging from 0 to 255. And that's because maybe you should know this already, if you know binary, 8 bits, the maximum value is 255 and the lowest value is 0, right? So then if you convert each octet, and the greatest value you get is 255, and 192.168.0.1 in binary would be the one right below there. So if you convert these from binary to decimal, those are the numbers that you get.
So for people who are, I see like a lot of people have taken discrete math and are in discrete math. How many IP addresses are possible if you have like these 8 bits? For 4 sets of 8 bits. Like this is something that I saw like Sumi, Morgan, and you guys were working on today for a set of bit strings. So this is your bit string, but then this is the one that is like responsible for your unique identification of your laptop or your device. So when you connect to a network, your device has its own person MAC address. But once you connect to a network, your network knows you by your IP address. So the correct answer will be like this. There's like 8 bits, like 2 to the 8, and then 2 to the 8, 2 to the 8, 2 to the 8. So you just keep multiplying them all together. And then it's a lot because each of these octet will go from 0 to 1 to 255. So you can keep multiplying and then do a permutation on it. Yeah, it's somewhere around 3 billion. So that's how many IP addresses or IPv4 addresses are possible. And each device can have multiple IP address. So the private IP address would be the one that is responsible for you would recognize you in your private network. So let's say if we are connected to the school network, all of you would have a private IP that starts with like 10.0 dot something something. So if I want to access your laptop being in the school's network, I would use that private IP. But for public IP, it is the one that is your external representation for the wide area network. If you are connected to a Wi-Fi or if you are connected to the internet, then if you would go to like mypublicip.com or something like that, it would actually show you the address which people can actually reach out to you using that IP throughout the internet. But for the private IPs, it can only be accessed with people who are inside the particular network.
Yeah, so that might be a little confusing because you're like, I thought an IP address was like a unique identifier, right? And it is a unique identifier, but it is only in the scope of your network, and you can actually be in multiple networks, right? You can be connected to the internet, but you can also be connected to the school, like school network. So we'll talk about that and how that works on the next few slides. So just going a little deeper into public IP address, defining it. It's an IP address assigned to a device by an internet service provider. For example, if you're not familiar with an internet service provider like Spectrum, a lot of you guys probably use Spectrum, and it's accessible from the internet. So basically, this is like your globally unique identifier, which allows it to send and receive data across public networks like the internet. That's how, like when you access something like YouTube, you're using your public IP address, and that's communicating to the YouTube server and coming back to you to that address, to your public IP address. And going further, just like YouTube, it's used to establish connections across the internet, including when accessing online services like YouTube or to download images from websites. And maybe like you played video games before, but like if they send you like 192.168.0.2, oh, this is your IP. Well, it's probably not because public IP addresses usually don't follow that scheme. But this is like what you don't want to get leaked. And if they leak this, then they can track you down to your close proximity, like around where you live. So that's what you don't want to get leaked. And that address is like what they could use to DDoS you. So just like a cool fact. And then we also have private IP addresses. So this is basically what's local to your private network. And these are IP addresses assigned to a device within a private network like a LAN. It's only recognized and accessible within the boundaries of the private network. So within this network, if you figure out your IP, you're probably going to see like 10.0.0, but whatever. Or you might see like 192.168 if your network is smaller. And basically, these are IP addresses that you can access like within your private network. So if you want to go from like a laptop to a laptop, like Nasir said, within a network, you would use your private IP address. And the reason why I'll talk about a little later, why you can't use your public IP addresses for that. But yeah, it's used for communication within the private network. For example, you can do like local resource sharing or local device communication. Just to reiterate, they are local to the private network and they can repeat exclusively. And what that means is that the same private IP will not exist in the same local network, but it can exist in other private networks. So I'm using the example 192.168.0.1 a lot, and it's because within a network, you can't have within the same network, like a local area network, you won't have 192.168.0.1 again. But within a different local area network, it can have the same IP address because it's like when you create variables in like when in like an if statement, if you create the variable in an if statement, it's local to that if block, right? But then if you want to access it outside of it, you can create a whole new variable and it'll have a whole new address. So like a comp sci reference. And basically, this address that is oh, sorry, this is for a public IP address, but basically this address is assigned to you by an ISP for the public IP address, and it's owned by the ISP. So I'll go into that when we're talking about that.
So a small trivia question. Why can't we have the same IP for two laptops or two devices in the same network?
Because network's gonna get confused on which.
Exactly. So because that's your unique identifier in the network. If you have two devices having the same IP, now if I want to reach out to your device, then the network is going to be like, oh, is it this one or that one? So that's where you have a unique private IP that's being assigned to your own device.
Okay, so here's like a really good example in my opinion. So basically this side of you where it says private IP, this is like the school network, for example, right? So each one of these like laptops or phones or whatever will represent a student. So within this local area network, you're basically using the 192.168.1.1 network. So you can see like they have this last octet is a little different, but you can see that the public IP is like completely different. And the reason why this is like all going to one IP is because of something called network address translation, which I'll talk about. But basically, the whole idea is that multiple devices on a private network, a local area network, can use one public IP address assigned by your ISP to access the internet. So here's another like example. So if your IP address got leaked, if your public IP address got leaked, it can be linked to you, but it can also be possibly linked to other people because your ISP might assign your public IP address to other people because they want to maximize the amount of customers that they give out IP addresses to.
So here's like, if you think about it, as we were just talking that there is like a limited number of IP addresses that are available. So what would happen? Because as you see over the years, internet at this point has grown to a point where you have like billions of devices connected to the internet. But the problem is, if you think about the public IP, they're actually gonna run out because you have more devices and less spaces to actually put your devices in. So that's where we are going to be talking about NAT gateways very soon. But this is where it makes it much simpler because in a private network, you can have multiple devices or even hundreds of devices connect to a single network where they have private IPs. But when they visit the internet, they are assigned a specific public IP. So for tens or hundreds of devices, you are just having one public IP, which is representing them on the internet. So if you want to visit like fragimtech.com, you are going to be from your private device, you're going to be talking to the router is going to talk to the ISP. But if two devices want to visit the same address or different addresses, they would actually be using the same public IP. So that's where you don't have to worry about your IP spaces running out.
Yeah, so for example, when we're on the school network, we all have the same public IP. So it's a unique identifier, but usually that's like in reference to your private network. And technically it is still unique, but yeah, that's like the idea. Okay, so there are different classes of IPv4 addresses. And just to clarify, IPv4 is basically what we've been talking about. There's also, I'm going to briefly mention this, but there's also like IPv6, and it's much more complicated, but it's because like Nasir said, we're running out of addresses, but an IPv6 is like, we have way more addresses, but we're not going to talk about that. So we're going to talk about different classes. We have class A, B, and C. And basically these are private IP networks that are commonly used because the amount of addresses that you have differ between classes. So usually within a really large network, you're probably going to use the class A. For example, on the school network, we probably have a class A we're probably using class A IP addresses because we have so many students and we are assigning a private IP address to each student, each device. Class B is like in the middle, and it's like, yeah, it's basically in the middle between small and large, right? So it's usually in the range of 172.16.0.0 to 172.31.255.255. And I'll talk about why these numbers are that way. Like, why is it from 16 to 31.255, blah, blah, blah. And there's a certain reason why that is, and we'll get to that later. And then we also have class C, which is like the smallest, and this is probably what your home network uses. If you search up your private IP in your home, this is probably what you get. That's like the range you should be in.
Yes, so a thing to note about these classes is because like when you would look at the internet standards, they have actually decided that this pool, and this pool of IPs is going to be only for private addresses. So whenever you see like an address that starts with 10.0 something, 10 something, you are going to be sure that nobody outside your network is going to be access that same laptop using that IP. So it's just better to be mindful of if you see something like 10.172 or 192.168. That's where you have to think about, oh, this is a private IP and it can only be accessed inside a particular private network, not outside that specific network.
Okay, so now we're going to talk about network protocols, which can get really confusing, especially for me when I started learning about it. So I'm gonna use a few analogies to kind of get the point across. But by definition, network protocols are defined standards for how devices should communicate and interact within a network. For example, network protocols, they define how data should be addressed, formatted, and how connections should be established. And there are a lot of other things that they define, but these are a few examples. So for example, let's take the English language, right? Rather than being a network protocol, we'll just call it a language protocol. And then we have the internet protocol, which is a real network protocol that exists. So for example, I said that network protocol defines how data should be addressed, right? And so in the English language protocol, we address people by their names or their pronouns by some unique identifier, right? And just like in the language protocol in English, we also have a way to address people in the internet protocol, and that's by IP addresses, just like we talked about before. For formatting in English, we have sentence structures. We follow a certain set of grammar, punctuation, and syntax, right? And just like in the internet protocol, we format packets or datagrams a certain way, which consists of a header and payload. That's how they know that this is an internet protocol data packet. And then for the English language, we also have a certain way of establishing connections, right? And that's handshakes, through introductions. With the internet protocol, it actually does not establish connections at all. It's it doesn't establish a connection before sending data. It's just oh, this is my destination. I'm just gonna send it. I don't care. You're just gonna listen to me. And even if you don't acknowledge me, I don't care. So that's how the internet protocol interacts. So that was just an example, and we'll get into a lot more network protocols, but it's important for you to understand what a network protocol is. And yeah, it's important for you to understand that.
Just for the network protocols, it's just like defining, over here we have a lot of people who speak different languages. So you can think of it as different languages. Like me and Sumi usually talk in Hindi or Urdu. And the way that we usually have the conversation is very different for how you would have it in English, the sentence structure, the everything. So computers do the same, even though they have IP addresses. In order for two devices to talk to each other, there's defined languages that are there to start the conversation, have the conversation going, and then just share data between the two devices.
And the reason why these standards are so important is because your laptops are all different manufacturers, right? You might have HP, you might have Dell. So if you guys didn't have established network protocols, if the world didn't establish that, then you literally probably couldn't communicate from one laptop to another. The reason why it's so important is because we want every single kind of device to be able to communicate. And it's by following these network protocols that they're able to communicate at all. Okay, and you want to talk about this?
Okay. So there's two types of major protocols which are used for data sharing among computers. How many of you have heard the word TCP or UDP in the past? So what did you know about TCP or UDP?
I don't know, I just heard about it a Python course.
Oh, okay.
That's really cool. Emma?
Oh, I won't be able to repeat it for either.
So for TCP and UDP, they are two different protocols that are defined on the internet for two devices to communicate. And there's certain pros and cons to each other. Have you seen the meme where it's for TCP, it gives the thing to the other person respectfully, and for UDP, he just throws it, even if other person gets it or not. So that's where TCP and UDP actually separate. So for TCP, it's actually used for stuff where you want reliability of the data, and you want to make sure that the data is received on the other end. And another one pro to it is that it's connection oriented. And so what happens is it does a handshake before it sends the data. So it's like the receiver is ready to receive and the sender is about to send. So they both have a handshake first and then it sends the data. For UDP, it is literally unreliable. It just throws the data to the receiver and it's upon the receiver to receive it or not. But where it's actually good is it doesn't need the handshake, and it's actually used by a lot of pretty much every real-time application, such as YouTube, where you don't have to, where the YouTube server could just broadcast the thing and it doesn't have to depend on the receiver actually receiving it. Or it can keep resending, or when you start receiving, it'll actually buffer. You have seen the buffer that's going there. So if you would look at YouTube or any other video sharing platforms, it actually uses UDP in the background. For TCP, it is used where you are like, where you want to really make sure that the delivery of data happens. So that could be like part of, and you want to maintain the integrity of the data. Like you don't want have the, like the heading of the email and then miss the everything and then just the signature. So that's where TCP actually helps you. And this is where you are, whenever you have a TCP connection, you can ensure that the data will be transmitted without being, without the integrity being affected.
Yeah, I feel like that was a really good explanation. So yeah, that doesn't mean UDP is bad in any way. A lot of times the reason why we use it in real-time applications is because it's connectionless, right? You don't have to establish a handshake. And the reason why that's important is because the handshake costs time. And if your video took like, it made like, imagine for every packet it's sent, it's like handshake, here data, handshake, here data, handshake, here data. It would take forever and you'd get like mad at the platform for being laggy. So that's when we use UDP. Okay, so here now we're talking about network address translation, which is like when I was talking about like the when I was talking about public and private IP addresses, how that all works. So that's where NAT comes into play, and also it's also known as network address translation. Basically, it's a technology used in networking that translate private IP addresses between different network domains. So, like Ms. here said, it's just like a repeat of everything. It allows for multiple devices within a private network to share a single public IP address. So we have like everyone has a public IP address here. It goes to the router and it all communicates through a single public IP address, which we all share.
So,
Oh, yeah, it's just like with the help of that, we can use less IP addresses, therefore we won't like run out. And that's it.
if two of you who are over here and connected to the same internet network, it's most probably that when you would look for your public IP address, you're gonna get the same public IP. You have a question? But yeah, that's where NAT gateways are there for, in order to like, because as we knew that the IPv4 addresses were running out, so this was the technology that was like brought in. And there's like, yeah, that's where it allowed you to have multiple, yes.
When we disconnect the Wi-Fi, it will change that.
Yes, so here's something we are gonna be talking about DHCP really soon. That's where like the private IP addressing will be covered. But if you think about it, the school network might only have one public IP. And the private network is actually like designed by some automation that whenever somebody connects, they get a new IP. Whenever they disconnect, the private IP is lost. But the public IP still remains the same because that's what the representation of the school's internet is for the whole internet, right? Does that make sense?
Yeah.
Okay, so yeah, we're talking about what you were asking about right here. So the way we get assigned private IP addresses is right here. So it's called DHCP, also known as Dynamic Host Configuration Protocol. And this is a network protocol that helps devices on a network automatically obtain an IP address and other network configuration information. But basically what it does is within the school network, we all get assigned IP addresses automatically, right? We don't have to go to a computer, set an IP address, and then communicate within our network. We just automatically get one when we connect to the internet. And that's all because of DHCP. And there's a lower level communication that occurs within your device and with the router or whatever device that's giving out the addresses. But basically what happens is DHCP sees that a new device connected, and if it doesn't have an IP address, it'll be like, hey, it'll offer you an IP address. It's like, hey, do you want an IP address? And it'll be like, yeah, I don't have one. Can you give me one? And then it'll be like, okay, I accepted your IP address. And then now it has an IP address. So you don't have to know like everything at the lower level, but that's how that happens. And maybe if you already had an IP address, because what the discover message does, it looks for devices that connected to a network. And if you already had an IP address in the acknowledgement stage, you can be like, actually, I already have one, it's okay. And that's how errors don't occur during this process. So it's very great that we have this protocol, because if we didn't, then we would have to manually assign it every time we disconnect and connect.
I have been at places where we didn't have a DHCP protocol configured. So in a small network, what we had to do is like whenever you join the network, you have to actually set a static IP. Like whenever you join the network, your IP will be this 10.001 or something. And you had to like change your computer configuration every time you join it. And then anytime you like leave it, you have to rechange it again. And the problem was, let's say I was using 0.1 already, and we didn't have DHCP. And you join in, and you don't know whoever one is using 0.1, and you try to configure yourself to be 0.1. But then that wouldn't work, and it would stop me and you from your work, because we both will be assigned the same IP and it would stop it. Nowadays, I think it's stable. But for DHCP, it doesn't do any of that. It keeps a table of every MAC address mapped to a certain private IP. So whenever a new device joins in with their MAC address, it just assigns a new IP which is not used by anyone else, and the device accepts it. A little technical part about it is that every IP for a private device has like a lease duration. If you would like see on your Windows desktop, or when you would go to your IP configuration, it tells you like this is the time that this IP is leased for you. But you can renew the lease before it expired to like keep the same IP if you want to be in a network with the same IP.
So obviously dynamic or DHCP is very useful within like large networks especially. But let's say you have like it's not always that you'll be using this, because for example, what if you have a printer, right? Printer, you probably don't want to get assigned a new IP every time. So with things like that, that's when we use a static IP where you manually go and configure and make sure it stays the same forever. So just putting that example out there. Okay, now we're gonna talk about DNS.
I call it DNS. Okay, does anyone here actually know what happens when you type in google.com and hit enter? No, have you ever thought about that at all? It's kind of weird. So this is where DNS comes in, which is another protocol. So DNS stands for domain name system. Basically what it does is your computer is stupid. It only knows zeros and ones. It doesn't know what the hell google.com is. So basically it can translate human readable words like google.com and translate that into an IP address, which is just zeros and ones at the end of the day. And a domain basically has like 4 main things. It has a protocol. So you've probably seen HTTP, HTTPS like that. So that's a protocol we'll talk about. Then there's subdomains. Basically, you might see this like docs.google.com when you're on like Google Docs or like slides. That's like a part of the domain. That's like another part of it, kind of type of thing. Then there's actually domain name itself. So you see like google.com, youtube.com, whatever. That's like the main domain. And then the top level domain or TLD is the com.net, gov, edu. That's what the TLD is. And basically, again, your computer has no idea what that is. So DNS will go and take care of that. And we'll talk about exactly how that works. So basically, the really high level overview of it is that they use something called DNS servers. And essentially what it is it comprises of 3 things. So it kind of goes in phases. So the first thing is that if your computer actually went and looked at google.com before, it can have it in cache, or basically it remembers what google.com is, and it can grab that for you and then go to the website itself. And that's called a subresolver. Basically, it's just your own computer doing that. If your computer doesn't have any information about what google.com is, let's say you've never been on google.com on your computer before, it'll go to the next step, which is your local forwarding server. Basically, you can think it's like your router essentially. So your router might have an idea of what google.com is. If that has no idea, it goes to the last one, which is the recursive DNS server. And this is where it can go basically search over to another DNS server where the IP address is. And you'll see a slide on the next one about what that is. But usually these recursive DNS servers is your internet service provider, so your ISP, so like Frontier, Spectrum, whatever. There's also other like DNS servers like Google DNS, which is 8.8.8.8, or Cloudflare, which is 1.1.1.1. If you prefer your privacy, use Cloudflare or just give all your data to Google, whatever. So this is how DNS servers basically work, and it'll make a lot more sense if I go through it. So I mentioned the first time, your computer might have an idea of where google.com is. You've been to google.com lots of times. It's not going to go through this whole line shenanigans because it already has it. That's the fastest way to do it. So if it has it, it'll go straight into google.com and go to the internet. If it doesn't have it, it'll go to the second one, like your router. If your router doesn't have it, it'll go to the next one. And that's where it gets interesting. If your router doesn't have it and your computer doesn't have it, it'll go to recursive DNS server. So your internet service provider, like Spectrum, Frontier, whatever. This is where it gets interesting because basically now it has to go and do this like whole dance trying to figure out what it is. And the way it does that is through something called name servers. So these name servers will basically a way for this recursive DNS server to go back and forth trying to figure out where this website is. And it does that in little chunks. So we mentioned it's called google.com, right? So what it does is actually it goes basically to, it'll look for then .com, then google.com. So this very top one on number 3, where it says root name server, this is the .name server. So basically what happens is this DNS server, recursive DNS server, will go to it and ask, hey, root name server, do you know where google.com is? Because that's where your computer wants, right? And it'll say, oh yeah, I don't know where that is, but the .com name server will know what it is. So now the recursive DNS server will say, hey, .com name server, do you know what google.com is? It's like, no, I don't know either, because it only knows what .com is. It'll be like, I don't know what that is, but I know google.com might know it. Then the recursive DNS server will take that information and go down to google.com's name server, and ask google.com's name server, do you know where google.com is? It's like, oh yeah, I know what that is. I'm google.com's name server. And it'll basically go spit out the IP address to it, and then you'll get the IP. And then your computer actually knows how to use that, and then you get Google. That makes sense? Any questions?
Why didn't you just go straight to Google.com?
The reason why is because it actually doesn't know how to get there without the name server. So basically you can kind of see it as like a hierarchy. So like the root name server is on the very top, and it like trickles down to try to find its answer. It can't just jump straight there. But the moment you actually go to it, it does this whole dance and gets to google.com's name server. It'll probably get stored on your computer, so it doesn't have to go back to it. So like when you're clearing cookies or cache and you're wondering why, like, oh, I type in a website and it takes forever to load, it's probably because it's going through this whole thing. And then once you browse through it again, it's just boom, boom, boom really fast. It's because it already has it there for you.
I think just like what you're asking, to be more specific. So the reason why it goes from .com name server to google.com name server rather than .com to I know google.com is because it knows the name server's IP, right? It knows the server's IP, but it doesn't know google.com's IP. So that's like the difference.
Yeah. Any other questions?
So there's like Cloudflare and your ISP, like they all have their own name servers, or
Yeah, well, there can be different name servers. There's not only one. So like for Google example, they might have like 5 of them, but they all have an idea of where this IP address is.
and then how does that name server get updated when there's like a new website?
That's up to like the administrators, I'm pretty sure, is the update. Yeah.
If you purchase a domain and you map an IP to it, like whenever you want to host your own website, what it does is you would have a service provider for that domain, like Namecheap or Hostinger or anything. And when you would enter your IP, it would say like DNS propagation would take like 72 hours, 2 days, or even 1 day. So what the administrator or the system does is it updates, or it lets every other DNS server know that this address is now mapped to this IP.
Any other questions? Also, this is good to know, like for interviews too, because people might ask this a lot, because it's like, it's good to know. Good, okay.
I can talk about this. Okay, so we kind of went. I think we kind of introduced it. I'm not sure if we did in the intro to Linux slides, but we like maybe talked about or like introduced Nmap. But basically, Nmap is a free and open source tool used for vulnerability checking, port scanning, and network mapping. So just for example, that's like an Nmap scan. We kind of did like a very extensive scan with the 3 options -S, -C, -V. But basically, it scans the IP, and okay, you see a domain here, but it's scanning an IP because like we just talked about, right? DNS translates it to an IP. So it's a domain, but it's also translating to an IP there. So that's what it's scanning. And when you scan it, you see all these ports open. You see port 22, 25, 53, and you can also see what protocol they're running on. So SSH 22 is running on TCP. And you can see more information about them. You can see that they're open, what they're running, things like that. So how does this all work, right? Like these tools, how do they even like scan for information about these targets? So how they work is that Nmap specifically utilizes the SYN, and ACK flags and TCP packets to discover active hosts and open ports and even more information. So we'll talk about that in the next slide, but these are the 3 things that are used in order to get more information. Okay, so there are 2 like primary scans that we'll be talking about. So with the SYN scan, what it does is that it sends a series of SYN packets to the target's device IP address and specific port numbers. We usually use the scan to quickly identify open, closed, and filtered ports. So this is like part of TCP, right? We talked about TCP UDP. This is the SYN scan is the SYN flag is part of TCP, where it like does all the handshake all the handshake stuff. And the SYN packet is one of the packets that are used within when you establish a TCP handshake connection. So what the SYN scan does, it sends a SYN packet and to the target, and it requests to establish a connection. If it's open, it'll send back a SYN packet, and then Nmap will stop the connection with an RST packet, terminating the connection. With an ACK scan, though, it's a little different. It'll send the same kind of information initially. It'll send a SYN packet, but by the way it responds, it'll be able to determine if the port is filtered or not. And what I mean by filtered is if there are firewall configurations or not, because within a very secure network, you're probably going to have firewall configurations that don't allow just random packets to fly in. So what it will do, it will do the same thing as a SYN scan. It'll request to establish connection. And if the target port is open, it'll respond like a SYN ACK packet, just like in the SYN scan above. But if it's filtered, it will just fail to respond, and therefore you could probably assume that it's filtered.
So it's a lot of new terminology that is there. This is more towards like the networking side of it all, and how do what type of packets are there, and how do SYN scans or ACK scans work. The important thing about, or like in order to summarize this or to have like a really high level overview on this, you can think about it as like different ways of scanning, but by using like different methodologies where the SYN scan actually waits for the response and then like derives some results. But for ACK scan, it actually also gets you like the firewall configuration. If there is something like, let's say you have a database which has a lot of important stuff which you don't want even people in your own network to see, right? Like, let's say there's a database running on the school system where it contains every one of us person's personal information, and they don't want us to see that. That's where they would have configured like their firewall for people even inside the old private network to not be able to visit that database. So this is where this actually helps you get a very high level overview of what the network looks like, what do the devices look like, what ports are open, how can you get in, and just to understand the target a little bit more.
Okay, so I promise you don't have to memorize this. This is just like a table for your reference, but these are common network ports that exist, and you'll probably see during like red team or penetration testing engagements. So a lot of like the popular ones like SSH, people just know that SSH runs on port 22. Like that's just, it's not like you have to run on port 22, but it usually runs on port 22. And that goes for every single service. So the second row or the second column is the service name, and then the first column is the port number. But these are what they usually run on. And for things like DNS, it usually runs on 53. HTTP usually runs at 80. So yeah. So this is just like for your reference, but yeah, I just want to put that out there.
Believe me, you don't have to remember this, but like after working in this stuff for like 2 days or 3 days, you would like know exactly on top of your head, like what's the port for SSH would be like 22. So once you like get around or play around with all of this a little bit more, it kind of like just gets in your memory. Just the important thing to know about this is like if you see a port like 22 or 80 or 443, there would be a point where you would just know that 443 maps to HTTPS. So when you would like go to a site by HTTPS google.com, it's actually google.com:443, but you don't see it. And for 80, it's like when you go to a HTTP site, it doesn't show that it's going to the port 80. So browsers by default assume that you are going to the website is running on port 80. So these are like the default ports which are generally used for these programs.
And I just want to point out, because it's kind of good to know, but if you didn't know the difference between HTTP and HTTPS, the S stands for secure. And basically, if you go to a website and it doesn't have like a little lock symbol, or it says HTTP rather than HTTPS, you probably don't want to go on it and like send all your information. That's like what a lot of scam websites use, because they don't want to like pay for a certificate, or they don't want to configure a certificate, stuff like that. But basically it's unencrypted, and if you were to analyze the data going between you and the server on an HTTP web server, then you can probably decrypt it and figure out what's happening. But with HTTPS, it's much more secure because your communication is encrypted, and therefore you can't just like look at the communication that's going on and be like, oh, hey, this is like your bank statements or whatever, things like that. So just a good thing to know.
Yeah, also like HTTP actually isn't even encrypted either. So like, don't ever do this. But like, if you're like at a coffee shop, there's like programs that you can actually use, and it's probably good to mess around with called Wireshark. Basically, you can see every single packet going over the network and seeing all the network traffic that's happening. So if someone got scammed and went to some like fake website that was like a banking website, and it was HTTP, and they typed in their username and password, and you saw that network traffic and open it up, you'd see their username and password just in plain text. So it would just be their actual username, their actual password. It wouldn't be scrambled or anything with like data it's hard to decrypt. It'll just be there in plain sight. So like people will actually do that. They'll set up like phishing scams where like they can go to a coffee shop and try to get people to go to a fake bank, whatever. And so if like HTTP is not there, they can just read your password and username, like nothing basically. So yeah.
For the security people out here, if you want to like explore how the HTTPS encryption works, you can like look into TLS and how it actually starts the connection between two desktops or two devices, and how do they share keys, such that even if there's someone in between listening to the traffic, they won't be able to decrypt your data. So that's there for HTTPS, and it's like try to don't enter your personal information if you are ever on an HTTP site. Like try to find the HTTPS version of it first.
Okay, and then now we're gonna go into firewalls on Linux because we left this, we didn't talk about this in intro to Linux because this is more like on the networking side. So we're gonna talk about it now. But just to recap, also there are like hardware firewalls, which we mentioned as a device before, but then there are also software firewalls. And this is a security mechanism that acts as a barrier between you and your computer or network, just like a device firewall. But it also controls the flow of incoming and outgoing network traffic based on rules. So there are two like popular, or there are two like softwares that you can use to configure firewalls on Linux, and they're known as UFW and IP tables. And I think UFW is like way more easy to work with. So we'll work with that. But UFW stands for uncomplicated firewall. And it's a tool for managing firewall rules on Linux. So these are like a few commands. You don't have to memorize them or anything. It's just there for your reference. But this is how you would configure firewalls on Linux. It's very simple. Like it's not like, oh my gosh, like I have to know all this stuff. It's like very simple. You just enable it. You tell it what to deny or allow. Tell it the port number, and that's it. It can get more complicated if you wanted to, but at the very core, you're probably just going to be like specifying like the port number and what traffic you don't want or you want to communicate between that port.
Yeah, and like the funny thing is like UFW actually uses the other IP tables in the back, like basically in the background. But UFW is basically there just to be like, I want to allow this, I want to deny this. And to give you like an example, let's say like you're a web developer, right? And you have a website that you're trying to make, and you're like, oh crap, I don't want anyone to see this yet. It's not ready. So knowing that like the ports for a website is either 80 HTTP or 443, you can basically just do sudo UFW, and you can pick deny if you don't want to see it, or if you want people to look at it, hit allow, then the number 443 or 80, or you can do both of them. And that would allow or deny. It's like that simple. And if you want to delete it, you can just do what's on the bottom too. The thing about IP tables, if you want to like get into it, is it gets way more granular. So it's like, well, I want people to access this, but only from this way or that way. Or like I want to like send traffic this way, but go that way. Like you can get way more granular just rather than just accept, deny. You can have it be like way more complicated. And some people might want that when they're doing networking like that. But I would suggest for now, don't touch it unless you want to. But yeah.
But it's good to be like familiar with how this works because although like the red teaming side of it is important, or not penetration testing side of it is important, like you also want to be able to think how like the people that are defending their network think, right? Because if you know how they think, then you can think how to abuse what they've been thinking. You know, it's like you want to know both sides of it. So.
Yeah, and something else to remember too is that even though they block something on the firewall, if you're on their actual computer, so let's say like you they have some application running and it's vulnerable and you hacked into it and you got in, and they're like, oh yeah, I have another development website that I've been working on that's firewalled and now they can't access it even though they're on my computer. That's not true. They just firewalled it off externally. So you hacking into initially, you couldn't see it, but once you're on there, you can see it locally on the computer now because it's only externally they're blocking stuff. So if they had like a development website that they're working on, and let's say like it was like, oh, I'm working on a website for people to do transactions and stuff, and they actually had like data there, just because they thought, oh, I firewalled it off, it's safe. if you had it running on your actual computer firewalled off, you can still access it if you had access to the computer. So firewalls aren't like oh, if they get on, I'm saved. It's more of it's like a preventive measure to make sure people don't get on initially, not afterwards.
Okay, and then so these are like the network commands that we didn't mention in our intro to Linux slides, but these are like a few of them. And we have like IP tables and UFW there, but these are like some really good ones to know. So there's ifconfig, which displays or configures network interfaces such as IP addresses, netmasks, things like that. So and then there's also like IPA, which I most often use, like IP space A. You can type that in your Kali machine. You can probably see it, but that'll like display your network interface information. So like your private IP address, and your network interface card, just very basic information about your network. And then ping. So this is basically what it does. It sends an ICMP echo request to a specified IP address to basically check for network connectivity. So sometimes like, especially with Macs, I don't know why, but like you'll connect to a network and it's like the Wi-Fi bar will like say it's connected, but then when you actually try to connect to the internet, it doesn't connect. And that's probably because you don't have like an IP address or there's like an issue. So the way to like very specifically verify that is by sending a ping request to a website that you know exists. And usually I use like 8.8.8.8 because that's Google's DNS server, and I'm pretty sure Google won't be down anytime soon. But that way you can check if you actually have connectivity or not to the internet. So yeah. And then there's also netstat. Usually you use netstat with like a bunch of options, which we can like talk about later. But basically it just gives you information about active network connections, listening ports, like locally on your computer, listening ports, routing tables and network interface statistics. And then we have NS lookup, which is a tool for looking at DNS lookups and things like that.
So just a important thing about netstat and NSLOOKUP. For NSLOOKUP, you use it on your local network on your local laptop or local device to actually see what applications are you running, or any of these applications are actually using any open ports. So that's when netstat is really helpful. For NSLOOKUP, as Bryce was earlier mentioning about DNS servers, you want to see what IP does google.com or facebook.com is mapped to, and you don't want to actually visit facebook.com. So you can just type NSLOOKUP facebook.com and it'll do the DNS search for you and provide you with the IP along with, I think it also gives you the DNS server that it got it from.
Okay, so that was it for like all the theory stuff. Now we're gonna like just do some practical application. So the lab for today is like always, it's like related to the homework. But for this week's homework, it's basically I put everything on a PDF, and we have some questions as well as some like try hack me rooms, which is like a website that has a bunch of like labs that they themselves. But I would recommend starting on the try hack me boxes. There are 2 of them, and then we have a bunch of questions. So yeah, you guys can check that out, and I can open it up on here for you guys to look at. But so this is what it looks like. You can just click on this and it'll take you to it. Oh, I'll just click on it. So yeah, this is what it looks like, and I already did it, but basically it has like questions and you can open each one. And you can read more. So this goes into like more of the lower level stuff in terms of networking, which is good to know. You don't have to memorize everything. I'm sure there's like a lot of information if you're just starting off. So you don't have to memorize everything. Just like answer the questions, just get like the general idea. And it'll also go into the TCP/IP model. We talked about ping. It'll also talk about traceroute, and this is like some DNS stuff. And then we have another one right here. And by the way, like you can use Google for this stuff, but a lot of the information will be provided in the reading above. So if you like don't find an answer right away, it's probably up in the reading. And then we have intro to LAN, and this might seem like a little kiddish, but it's like really good to understand common network topologies. So this is like a common network topology that exists, and it's called a star topology. So you can learn about that, and it's just really good to know, because you might be able to like figure out if you're like doing an engagement, you might be able to like figure out what kind of topology they're using. And it'll also go more into like local area networks. So you'll also learn about subnetting. And also we talked about DHCP and then also the ARP protocol, which is just like how it establishes like the initial connection between that within a local area network, things like that. So yeah, I would recommend starting here. So yeah, if you guys see the link, it's straight.
That's. How's this?